All right, now we are back and we're talking about hurricanes. I will suggest this. If by this point you haven't watched the film Inside the Superstorm, which talks about Hurricane Sandy, it's a really good tool to help visualize a lot of the things we're going to be talking about, how hurricanes form and grow. So, if you haven't watched that, maybe come back to this video, watch that film, and then come back. It'll help. Now, what is a hurricane? It's a tropical cyclone. That's the actual scientific name for it. It's a cyclonic storm that forms in the tropics, and the winds have to be sustained 74 miles an hour. So constantly at 74 miles or greater. You can have gusts, but that's the constant. These form in the northern hemisphere, they rotate counterclockwise. If they form in the southern hemisphere, they're going to rotate clockwise. Remember, that's to do with the Coriolis force, right? And as we talked about before, right, they form around low pressure because in an area of low pressure, the wind is going to move towards it. And as it moves toward it, because of the Coriolis force, it kind of spins in. So the faster it's moving towards that area of low pressure, the faster it spins. You get the hurricane. So there are different names. A hurricane is what we call it in the northern hemisphere. So the Atlantic Ocean has hurricanes. There's hurricanes off the coast of western Mexico. But other parts of the world, in Southeast Asia, so the Philippines, China, Japan, they call them typhoons. It's the same storm, just different names. If it happens in the Indian Ocean, it's called a cyclone. And then in Australia, they call them tropical cyclones. All the same thing. So the pattern is this. All cyclones, they have what's called an eye. It's an area of very low pressure with no horizontal wind, only vertical wind. So if you're in the eye of a hurricane, it's extremely calm. In fact, it's so calm, there's no clouds above you. So even though you're surrounded by all these rain clouds, at the very center, you can often look up and see stars at night. Surrounding the eye is called the eye wall, and this is the strongest part of the hurricane, right around the eye, the strongest storms, the strongest wind, the strongest rain. And then spiraling out from that are these long bands of rain. So the winds are actually slowest in the very exact center of a hurricane. And then right surrounding it, they're the fastest and then gradually dissipate out. And the eye is crystal clear because that is the center of low pressure. So here is Tropical Storm or Typhoon Hainan, one of the strongest that ever hit the country, ever hit Asia. Kills over 6,000 people in the Philippines alone. You can see right here from space that dark dot, and that is the eye. So within this dark dot, there's no wind at all. Completely calm, no rain. Surrounding it, winds of over 200 miles an hour, very strong rain, and you can see these long spiral bands just kind of hanging out. So this tracked across the Pacific Ocean. This was in 2013. It finally ends up hitting China and dissipating. But when across the Philippines, the winds combined with the rains, over 6,000 dead alone. So how strong do they get? Well, think of this. How much fuel? And the fuel is warm water that turns into water vapor. So water that is very warm that evaporates, right? And then what happens is you have that evaporated water vapor that can condense to liquid. And when something condenses, so when something goes from a gas to a liquid, right? It loses energy. It releases that latent heat we talked about, which is fuel. And what happens is that condensation releases heat into the surrounding air, which evaporates more water, which turns back into rain, which releases more heat. And this is feedback. They feed each other. It's almost like rolling downhill. And the faster it goes and the faster it goes, the stronger the hurricane gets. So in other words, how much water vapor condenses to liquid? The conditions are right. It has to have warm seawater. Theoretically, if there was warm fresh water, a hurricane could form, but there is no body of fresh water that is large enough and warm enough. The Great Lakes are far too cold and not even large enough. So basically, it has to have seawater that is warm, and we're talking the surface of the ocean is be about 85 degrees. So that's pretty much just the tropics. Here's a cross section, right? And these are probably almost 1,000 miles across back all over. Here is the eye. It's an area of very low pressure, right? So low pressure. So the wind wants to rush in here. It wants to go in. But remember, as it goes in, it starts to curve, and you get that spiral right here, right? So the winds spiral into the center. And they're going into the center, and when they get to that low pressure, they go up. So they spiral, 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 they get to that, and they go up, and they flow out. And as they come in, all that moisture. The warm water here gives moisture in the air, and it just sets the storm happening. So these are basically just strong bands, extremely strong bands of thunderstorms. Now, a hurricane just doesn't occur out of nowhere. It actually starts as a tropical disturbance, which is a very, very kind of weak storm. But if the conditions are right, you have enough fuel, enough warm water, enough sunlight, the right kind of wind situation, the storms get stronger and they build. Remember, they kind of like a feedback engine. So like it's starting to roll down a hill, and it moves into a tropical depression, which has a little bit of organization. And then that becomes a tropical storm, which is basically like a baby hurricane, and eventually a hurricane. So it has this growth. Hurricanes just don't go like that. Okay? So here's an example. In the Atlantic Ocean, the ones that we talk about in the United States, usually what happens in the springtime or the late fall is warm, dry air blows across the Sahara Desert here in Africa. And when it encounters the moist air here over the ocean, now you have that warm, moist air, that warm, dry air, you start seeing a big bunch of thunderstorms form. Now, 9 times out of 10, that can break apart. But if there's enough warmth, those thunderstorms can grow. And so now it goes from just being this bunch of clouds, you start seeing a little bit of a pattern, and a little bit more, and you start seeing a little bit more rotation, because as it grows in strength, the winds become faster. And the faster the winds go, the more they curve. And the more they curve, the more they focus. And so it just grows, and now you have a hurricane. You guys see the eye right there. So gradually, they build. And generally speaking, in the Atlantic Ocean, the tract is this way. It kind of goes this way and then up the coast. And as we'll talk about, that also has to deal with the fact of the different air pressure masses we talked about last chapter. Generally, in the fall, it's an area of high pressure right here, and low pressure steers around it. So, if you've ever heard it was a Category 4 or Category 5 hurricane, we can rate strengths, just like we have for tornadoes and we have for winds. The Saffir-Simpson scale is the most common one. Okay, and it's basically how we measure on wind speeds. We can use satellites so we can see the wind speed. So the first level, Category 1, has the winds of 74 miles an hour, all the way up to Category 5, which I believe is 200 miles an hour. Okay. Now, hurricanes, the reason that they only happen at certain times of the year and certain locations, a couple things. It has to have a lot of warm water. Water that's about 80 degrees Fahrenheit, which is pretty warm. By comparison, Lake Michigan never goes above 70, right? Because that water that's 80 and above evaporates quite well. So it basically turns into water vapor, the fuel hurricanes need, okay? There also must be no wind shear. If the wind in the upper atmospheres is blowing differently, it doesn't let those bands form. It breaks them up, okay? Now, how do we do this? How do we know all these things? How do we measure them? A couple things. Satellite technology has been invaluable. We can monitor these from space. We can see where they are. We can also use the technology to measure rain. We can measure atmospheric temperatures. Lots of data. We also have buoys in the ocean that can monitor water temperature as well as wind speed. And oftentimes, they will fly airplanes to a hurricane, and they drop these buoys. And now you can't see it because of my lovely face, but this is basically like a big, huge parachute that lets this big, long metal buoy fall through the hurricane. And what's in there? You have a GPS antenna so it knows where it is. It has an air pressure monitor so you can monitor air pressure, air temperature, wind speed, all of that. And these have radio antennas so they just beam the signals back. So, the geography of hurricanes is limited by what it needs, right? It needs to have warm tropical oceans. So, you're not going to see a hurricane form near Antarctica, too cold. You're not going to see one form off the coast of Alaska or Argentina, too cold. Now, the other thing is, where do they go? What path do they take? Because they all happen in the summer. That's when you have high pressure over the oceans. So the book mentions one and your movie mentions one, the Bermuda High, an area of high pressure over the mid-Atlantic. And hurricanes basically always skate around that. Now, remember that hurricanes also are a product of the Coriolis force, right? That curvature of the wind because of the rotation of the Earth. But remember, we talked about that the curvature, the Coriolis effect, doesn't happen near the equator. So, hurricanes have to happen in the tropics, which is basically from 0 to 30 degrees north, and then 0 to 30 degrees south. So a band across the world from 30 north to 30 south, except for right near the equator. So this is a map of all known hurricane paths, all these lines, where they start and where they end. And so you can kind of see clusters, right? So we always talk in the United States about here, the Gulf of Mexico, the Atlantic Ocean, right? So hurricanes generally start in this area and gradually go this way. I mean, once in a while they'll go this way or that way, but for the most part they go this way. And they break up or dissipate because by the time they get up here, the water's cool. Now, another area right here is off the coast of Mexico. So off, so say Acapulco or Mazatlan, this area is Central America. But here we don't hear too much about it because the hurricanes that form here, for the most part, blow out to the ocean, and there's really no one out here. So most of these hurricanes happen over the wide open ocean. And again, if it doesn't happen to humans, then we don't really care. So once in a while, one will turn inland and hit Mexico, but for the most part, they don't, right? But the most hurricanes in the world actually happen right here in the Pacific Ocean. So right here, this would be where Guam or the Marianas or the Marshall Islands are, warm water. And so the tracks generally go this way because there's usually high pressure right here. So this is the most right here. The deadliest ones that cause the most human loss of life, and we'll talk about that, happen right here in the Indian Ocean. Not as common, but when they do happen, the geography of it, we'll talk about it, makes the flooding the most of all of them. Now notice that there's none right here at the equator, right? No Coriolis force. There's none really far to the north. Now you'll also notice that here, they happen here in the Indian Ocean and Australia, but not over here. And that's because this area here, off the coast of, say, Peru or Chile in South America, the water is very cold. There's a very cold current of water that comes up here. So the water is too cold. And the same thing down here. But there is one. In 2004, there was actually a very weak hurricane that happened here. And we think because global warming has begun to warm these areas more so, we might start to see hurricanes in areas down here we've never seen them before. All right. That's part one of hurricanes. Let's pause this for station identification, potty break, shake up the sillies, all that good stuff, and then we'll come back.